This is the same integration packet, 14b, but this is now number 10. We see that we've got an indefinite integral. There are no endpoints here. That tells me I know my final answer has to have a plus c. I need to use u substitution, so I've got a lot going on. I've got a secant squared on top. On the bottom, I've got a square root, and I have a tangent. So when thinking about what to make the u value, I'm looking at this tan and the secant squared. The square root, I feel like I'm confident I can deal with that. I know that tangent's derivative is secant squared. So if tan's derivative is secant squared, then I'm thinking to make the tangent part the u. I know that because whenever I do a u substitution, I know I also need to do a du. Well, so if I have a certain thing that's u, I need to have its derivative available. So if I make the u tan, so then automatically I can start to rewrite this, square root of u on the bottom, then I know I need to have a du somewhere in this integral, right? We're converting all our x's into u's. Well, I happen to know that tan's derivative is secant squared x dx, and lo and behold, I have secant squared x dx. So all of that stuff becomes du. So my new integral in terms of u is the integral of du over root u. You could think of that as u to the negative 1/2 du. And now that's a simple power rule, so I'm going to raise it and cancel it, right? So I've integrated, the integral sign and the du go away. Well, that's all well and good, except I can't leave my answer in terms of u. I have to go back to x's, because u is just something I made up for myself. So it's really 2 times tan x to the half, or we could say 2 root tan x, and then of course don't forget plus c.